Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. Yesterday, we have completed with the explanation of chapter number 3, Current Electricity. Today, before proceeding towards the discussion of textual exercise, we will just have a glance at the topics. We will just revise as usual the topics which we have covered yesterday, and then we will start with the textual exercise. So I request all of you to keep the textbooks in your hand and also a pencil for writing down the answers. So let us first begin with the revision part. In yesterday's session, we have studied about what is an electric circuit. We have studied what are conductors, what are insulators, and two derivations. The first derivation was the formula which you obtain when the resistors are connected in series, and the other one was when the resistors are connected in parallel combination. I had told you what is a resistor. It is a two-ended component having a given amount of resistance between its two ends. So when you can say that these are the resistors R1, R2, R3, you can see the ends, both the ends of the three resistors, they are connected. So they follow the order of one after the other in a single line, and in such a case you say that the resistors are connected in series. What is the main property over here? The same amount of current flows through each resistor. How you can measure the amount of current? You can see here an ammeter is placed. R1, R2, R3. They are connected one after the other in a single line. The ends of these three resistors are connected. So they are in a series combination. If you measure the potential difference with the help of this voltmeter, it is V1 for R1, V2 for R2 and V3 for R3. The total, you can say, value of potential difference, that is V, between points C and D will be what? Sum of the potential difference across points C and D. So V will be equal to V1 plus V2 plus V3. Now you are going to apply Ohm's law. So what is Ohm's law? V is equal to IR. Now here you can see I have taken RS, because we are going to calculate the effective resistance in series combination. So S stands for series. So S, V1 will be what? I R1, V2 will be I R2 and V3 will be I R3. Now this value of V and V1, V2, V3, all these values we are going to substitute in equation number 1. So substituting in equation number 1, what was the value of V? IRS. So IRS is equal to IR1 plus IR2 plus IR3. What we have done? Just this values we have substituted in the equation, and now if you take I common, here if you take I common inside the bracket you will have RS. Here if you take I common inside the bracket you will have R1 plus R2 plus R3. I and I on both the sides will get cancelled off. So final equation is RS, that is effective resistance in a series combination, is equal to sum of resistance. So R1 plus R2 plus R3. If there are n number of resistors, more number of resistors, then the formula is RS is equal to R1 plus R2 plus R3 plus Rn. This is the formula when the resistances are connected in series. Let us have a glance at the characteristics. When the resistances are connected in series, the first we have seen is the current remains constant. So the same amount of current flows through each resistor. The effective resistance of the resistors is equal to the sum of their individual resistances. So RS is equal to R1 plus R2 plus R3. That is your third characteristic. What is potential difference? Total potential difference is sum of the potential difference across the individual resistors. V is equal to V1 plus V2 plus V3. Rs, that is the effective resistance, is greater than each of the individual resistances, and as it is equal to the sum of the resistances, this arrangement is used to increase the current in a circuit. Also, I had explained yesterday, when resistances or resistors, they are connected in series, they are connected one after another. If any one of them does not function, the circuit will break and there will be no flow of electricity. Now let us revise the derivation for resistors when they are connected in parallel combination. Here you can see why you can say that they are connected in parallel, because their ends are connected at both the sides. The ends of the resistors are connected to both the sides. So we can say that R1, R2 and R3 are connected in parallel between points C and D. You can relate geometry. You know parallel lines. Okay. So you can see in the form of parallel lines between points C and D. Hence we can say that the resistors are connected in parallel. Now here the unique property is potential difference remains constant. Whereas in series combination, same amount of current was flowing. So current was constant. So V is the potential difference between points C and D. Now here current flowing across each resistor will be different. For R1 it is I1. For R2 it will be I2. And for the third resistor the current will be I3. So, what will be the total amount of current? It will be the sum of the currents flowing through each resistors. So, total current I is equal to I1 plus I2 plus I3. This you give as equation number 1. As we have applied Ohm's law in the previous derivation, similarly here also you are going to apply Ohm's law. Here you know the formula for I. I is equal to V upon R. But as I have told you, for series, same applies for parallel. Parallel is denoted by small p. So R of parallel combination. Series, it was R of S. So series combination. Small things you have to just remember. I1 is V upon R1. I2 is V upon R2. I3 is V upon R3. Now this values of I1, I2 and I3, this values you are going to substitute in the previous equation, that is equation number 1. In place of I, you will put V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Take V common. What will remain in the bracket? 1 upon Rp. Here if you take V common in the bracket, it will be 1 upon R1 plus 1 upon R2 plus 1 upon R3. V on either sides will get cancelled off. So your final formula is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And for n number of resistors, it will be 1 upon Rn. Both these derivations you have to study carefully. Formula you have to remember for solving the numerical examples ahead. Now you can see here, if you have to study the characteristics for parallel combination, very simple. Looking at the derivation you will come to know. First is the inverse of the effective resistance, that is 1 upon Rp is equal to the sum of the inverse of individual resistance. It is not R1 plus R2, it is inverse 1 upon. So the inverse of the effective resistance is equal to sum of inverse of the individual resistances. As you know, your current flowing through individual resistor is proportional. I1 for R1, I2 for R2. So the current flowing through an individual resistor is proportional to the inverse of the current, and hence what will be the total current? It will be the sum of the currents flowing across each resistor. Third, you can say here potential difference is constant, as we had studied for series. Okay, current there was constant. Fourth is effective resistance of the resistors connected in parallel is less than the least resistance of the individual resistors, and as it is the sum of the inverse, such a type of combination, such a type of arrangement is used to reduce the resistance in a circuit. Just this characteristics we have revised just now. about the effective resistance, about the current, potential difference, how the effective resistance is less in a parallel combination, and arrangement is used to reduce the resistance. This was all which we have studied up till yesterday's session. Now let us see a remaining small topic from this chapter. You have studied about electricity in this chapter. So what precautions you have to take while using electricity? One by one we will just discuss. Electricity, it plays a really vital role in our daily activities, in our daily life. But if not handled in a proper way, many of the accidents you have heard around you due to short circuit, due to overloading of the circuit, you have seen appliances catching fire, the entire house catching fire. So what precautions you can take at the general level? First thing is, who are at a risk from this mishaps, or you can say who are at more risk while using the electricity is small kids. So electric switches and sockets should be fitted at a height at which small children cannot reach, on they can put the pins or nails inside. Also the plug wires should not be pulled while removing a plug from its socket. Small children means at least you can say that below 5 years of age. They are very small. They do not know the results, the harmful results of not handling the electricity in a proper way. So this switches, sockets, where the children can do any type of experiments. They can put some pins, they can put some nails inside that holes. So all these things which are very dangerous related to electricity, they should be fitted at a height, because at a certain height the children will not be able to reach there and accidents can be avoided. Before cleaning an electrical appliance, it should be switched off and its plug should be removed from the socket. Many a times women have the habit of cleaning the mixers, the refrigerators, and you can see that it is in the position where the plug is not removed from the socket. And when you are cleaning an electrical appliance, many a chance you can make use of wet clothes, and water is a good conductor of electricity. So really it is dangerous to clean an electrical appliance when the plug is still inside the socket. So remove it out and switch it off, and then you can clean it. Third one is, one's hands should be dry while handling an electrical appliance, and one should use footwear with rubber soles. You have studied in this chapter about conductors and insulators. Footwear with rubber soles. Rubber is an insulator. It will not allow the current to flow through your body. So when you are cleaning an electrical appliance, see to it that your hands are dry. With wet hands if you are doing, then the chances of accidents increase, because water is a good conductor of electricity. Even your body has different ions of different salts in the form of sodium ions, magnesium ions. So your body also, it is likely to carry, to flow, to allow the current to flow through it. So see to it that you are handling the appliances with dry hands. And also rubber, here rubber soles, it is told, it is an insulator, so it will prevent the current flowing through your body and thereby protecting it. Also one thing you have to remember, if any person you see across getting an electric shock, you should not touch that person. Why you should not touch? What you should do over there, you should switch off the main switch, and if the switch is too far or you do not know where it is located, then you should remove the plug from the socket if possible. If that is also not possible, then you make use of a wooden pole or any insulate material which is made up of it is an insulator property to push the person away from the electric fire. Do not make use of your hands even if the person is your near and dear one, because it is very dangerous. If you touch the person who has already been who is getting an electric shock, if you touch him, you will also get stuck to him, because your body also will start conducting electricity and the output will be a negative one. So make use of insulating materials like wooden poles or plastic stools to just put the person away from the main source of current. So these are the different precautions which you have to take while handling electricity. If you take proper precautions, if you take proper care, then your family will be saved from the different accidents which are caused due to the misuse of electricity. On this page, we have about the precautions. Now we start with the discussion of textual exercise. So keep your textbooks open, page number 44. Question number 1. The first question is, the accompanying figure shows some electrical appliances connected in a circuit in a house. Answer the following questions. Now, if you refer this chapter's textual exercise, majority of the questions, means I can say all the questions are application based. Many few theoretical questions are there. No definitions, no laws, no derivations. They have given us the questions in the textual exercise. I will give you under additional questions. Don't worry about that part. But each and every concept, if you know very thoroughly, each and every formula, its characteristics, then only this application based questions you will be able to answer. So let us see what are these application based questions. So here you can see in this figure, some electrical appliances are connected in a circuit. You can see this table lamp. Here you can see some television, a small lamp. So all you can see, they are connected in a circuit. Now based on this diagram, you have to answer the first question. By which method are the appliances connected? Now here you can see the appliances are connected in a parallel combination. So the first answer is the appliances are connected in parallel or in parallel combination. Next one, what must be the potential difference across the individual appliances? Now you know, when the appliances are connected in parallel, then the potential difference is constant, it is same. So the answer is potential difference across all appliances is same. Now these are the application based answers, because these answers are based on the derivation which we have studied when the appliances are connected in series or when the appliances are connected in parallel. Third one, will the current passing through each appliance be the same? Justify your answer. Now, as you know, this is a parallel combination. So current flowing through each appliance will not be same. It will be different, as every appliance has a different resistance. So the characteristics for parallel which you have studied, that you have to apply in getting the answers over here. Fourth one, why are the domestic appliances connected in this way? Because the potential difference, it remains the same. And last one, if the TV stops working, will the other appliances also stop working? Explain your answer. On page number 41, you have studied, yesterday I have told you, when the appliances are connected in parallel, if any of the appliance it becomes non-functional, the circuit does not break as the current flows through the other paths. So rest of the appliances will keep on working. So answer is no. Other appliances won't stop working as the current flowing through them is along different paths. But if it is a series combination and if this was your question, then the answer would be yes. Have you followed all the four, you can say all the five answers? Which method they are connected? Parallel combination. What must be the potential difference? The potential difference across all appliances is same. Will the current passing through each appliance be the same? No. Why are domestic appliances connected in this way? Because potential difference remains same, and if any of the appliance stops working, the other appliances will continue to work because the current flowing through them is through different paths. Now we move on to question number 2. Question number 2 is, the question has given you different components over there. The following figure shows the symbols for the components used in the accompanying electrical circuit. Place them at proper places and complete the circuit. So the symbols they have given to you, it is nothing but a circuit diagram which you have in your textbook on page number 35. same circuit diagram, they have given blank empty spaces. So in that you have to fill the symbols and complete the circuit. Below the circuit diagram, they have asked you a question. Which law can you prove with the help of the above circuit? You can prove Ohm's law with the help of the above circuit. Next is question number 3, application based again. Umesh has two bulbs having resistances of 15 ohms and 30 ohms. Two bulbs, they are having two different resistances. The first one is having 15 ohms resistance, second one is having 30 ohm resistance. He wants to connect them in a circuit. But if he connects them one at a time, the filament gets burned. Answer the following questions. Which method should he use to connect the bulbs? He wants to connect them in a circuit, but if he connects them one at a time, the filament gets burnt. So he should connect the bulbs in series combination. So which method should he use to connect the bulbs? He should connect the bulbs in a series combination. Second is, what are the characteristics of this way of connecting the bulbs depending on the answer of question A? So what is your answer for question A? Series combination. So the characteristics for series combination, here you have to mention, as the bulbs are connected in series, what will happen? Resistance will increase. See the last characteristic which you have studied. This combination is used to increase the resistance in the circuit. So resistance will increase, so current will decrease, and hence the filament of the bulb will not get burnt. And hence he should connect them in series. What will be the effective resistance in the above circuit? Total resistance. So it is a series combination. So Rs is equal to R1 plus R2. Two resistances are there. Add both the values. 15 ohms plus 30 ohms gives out 45 ohms. See how the derivation which you have studied for series, the derivation which you have studied for parallel is applied in answering question number 1 and 3. So these are called as application based questions. Question number 4 I will keep aside because this question I will complete after you watch the practicals for Ohm's law, because they have asked about the nature of the graph and all. So when we complete the practicals on coming Monday for the Ohm's law, after that I will discuss towards the end, I will discuss question number 4. Question number 5, match the pairs A group, B group. Now here I have written answers in front of it. Free electrons, they are weakly attached. So the answer is, for 1 it is answer C on the B group. Current is equal to V upon R. Current I is equal to V upon R, Ohm's law. Third, resistivity Ra upon L. And fourth, resistance in series. It is used to increase the resistance in the circuit. I want all this match the columns, everything written in your notebook. As I have told you earlier also, if you see the questions of this textual exercise, big questions are printed. You can see the previous slide about the Umesh and all such big questions. No need of you to copy the question. You only put question number 3, put A and write the answer. Then put B, write the answer. Put C and write the answer. Even for your previous slide also. Here also, no need of copying all these questions. Only put the proper question number, that is question number 1, A in parallel combination, B this answer. Understood? So this way your work will be lowered. Then teacher, how to study? When you are studying this textual exercise, keep the textbook ahead of you, read the question from the textbook and study the answer from the notebook, because it is your board pattern. In board exam also, never you copy any questions. So here also I will not burden you more with copying of the questions. The only thing is your notebooks should be completed. Question number 6 is a homework for you. A very simple question. The resistance of a conductor of length x is R. I will just discuss. You can write the derivation on your own. Resistance they have given of conductor of length x is R. So length x. So length L is what? X. resistance capital R is R and area of cross section is small a. So capital A, area of cross section is small a. What is its resistivity? Write the formula for resistivity. RA upon L. Substitute the values. And what is its unit? Its unit, as it is resistivity, unit is ohm meter. So everything will not be spoon feeded in this chapter. Some part I will explain, some part I will give the answers. 1 or 2 parts you have to do it for homework. Because everything if I discuss over here, then your utilization of brain will not be done. Question number 7 again. You can say application based question. Read it carefully. Resistances R1, R2, R3 and R4. 4 resistances are there. R1, R2, R3 and R4 are shown, connected as shown in the given figure. S1 and S2 are the 2 keys. S1 and S2 are the 2 keys. Discuss the current flowing in the circuit in the following cases. 3 cases they have given. The first 2 I have explained to you. Third one you have to do on your own. Both S1 and S2 keys are closed. Both S1 and S2, if both the keys are closed, what will happen? The effective resistance of the circuit will decrease, and what will increase? Current will start increasing. So that is your answer. Effective resistance, as it decreases, immediately current will increase. Second case, if both S1 and S2 are open, if both these keys are open, exactly opposite, effective resistance of the circuit will increase and so the current will decrease. See, such very simple answers. Third one, it is a homework. I will just discuss. S1 is closed but S2 is open. What will happen here? Current will, so total resistance or the effective resistance, it will decrease. Current will increase, but this current will be more than in the second case and less than in the first case. I hope you have followed the answer for the third one. Utilize your brain and get the answer. So question number 7 is over. Again question number 8. Some part I have solved for you. Some part is a homework. I will discuss. Even though it is a homework, I will discuss it. 3 resistances X1, X2 and X3. Till now we were seeing resistances R1, R2. Here they have given X1, X2 and X3 are connected in the circuit in different ways. X is the effective or the total resistance. The properties observed for these different ways of connecting are given below. Write the way in which they are connected. You know 2 types of connections are there, series, parallel. Looking at the property which is given, you have to find which way they are connected. I is current, V is the potential difference and X is the effective resistance. First property they have given, current I flows through X1, X2 and X3. As you know, the same current I is flowing through all the 3 resistors. Then the 3 resistors are connected in series combination. Why? Because the same current is flowing through them. See how the questions are asked. Means your characteristics, every point of the derivation of both the combinations should be known by you properly. Then only such answers you will be able to answer. Second, X is larger. What is X? Effective resistance. Then the individual resistors. This is again a characteristic of series combination. So X1, X2 and X3 are connected in series, as the effective resistance in series is greater than the individual resistance. C, I have not answered. Why? After B I have gone to D. C is, X is smaller than X1, X2 and X3. So when effective resistance is larger, it is series combination. So when it is smaller, it will be connected in parallel. So the answer for C is parallel combination. Fourth one, D. The potential difference across X1, X2 and X3 is the same. Here current was same, so they are connected in series combination. Here potential difference is same, so they are connected in parallel combination. And E and F is a homework, because E they have told X is equal to X1 plus X2 plus X3. Means effective resistance is what? Sum of all the 3 resistors. So they are connected in series. And if you see x is equal to 1 upon x1 plus 1 upon x2 plus 1 upon x3 means they are connected in parallel. Simple applications. So we will complete our today's session by ending the textual exercise up to question number 8. In our next session that is tomorrow, I will be providing you with the additional question answers, and then we will end this chapter with the discussion of numerical and solved examples. So till then, I would bid a goodbye from my side. Stay at home, stay safe, and see to it that your studies are going on properly on time. Thank you, dear children.